Hello students. So today I'm continuing class for class 12 science. So today's topic is inverse circular function. So today also I'm continuing the same chapter, that is inverse circular function, and in the last class also we were doing the same topic, that is inverse circular function. So in that case, in that online class we finished 2 marks section, right? So let's start from 4 marks section. So let us prove that this is question number 1. The question is 4 within bracket tan inverse 1 upon 3 plus cos inverse 2 by root 5 bracket close is equal to pi. So you have to prove this LHS is equal to RHS. Now you can use the formula here, tan inverse x plus tan inverse y, isn't it? That means you have to convert this cos inverse 2 by root 5 into tan inverse, right? So you know that any inverse circular function can be converted into other inverse circular function. That means this cos inverse 2 by root 5 can be converted into other inverse circular function like sine inverse, tan inverse, sec inverse, cot inverse, cosec inverse, right? So in this case, this cos inverse 2 by root 5 should be converted into what? Tan inverse, because the first term is tan inverse 1 upon 3. Now let us convert this cos inverse 2 by root 5 into tan inverse, right? So let us write down the left hand side. So LHS is equal to 4 within bracket tan inverse 1 upon 3 plus cos inverse 2 by root 5, right? So let's convert this cos inverse 2 by root 5 into tan inverse, okay? So what is the method here? Let cos inverse 2 by root 5 is equal to theta, right? So or 2 by root 5 is equal to cos theta. So when cos inverse goes to the right hand side, it becomes cos, right? So what is the value for cos theta in this case? So cos theta is equal to 2 by root 5. So now this cos theta should be converted into tan now. So in order to convert this cos inverse into tan inverse, so first of all this cos theta should be converted into tan. So which formula is used now here? So now let us convert this cos theta into sin theta. So that tan theta is equal to sin theta by cos theta, isn't it? So you know the formula of sin theta in terms of cos, you know that, isn't it? So sin theta is equal to root under 1 minus cos square theta. So here cos theta is positive, so sin theta is also positive there. So put the value for cos square theta. So sin theta is equal to root under 1 minus, what is cos theta here? It is 2 by root 5. So it is 2 by root 5 whole square, right? So or sin theta is equal to root under 1 minus, what is that? 2 by root 5 whole square, it is 4 by 5. Or what is sin theta now? Which is equal to root over, now you can simplify it, that is 5 ones are 5 minus 4 is 1, that is 1 by 5. So or what is the value for sin theta? It is 1 by root 5. So now get the value for theta. We need the value for theta here. So theta is equal to sine inverse 1 upon root 5, right? Now cos inverse 2 by root 5 is equal to theta, and theta is equal to sine inverse 1 by root 5. That means this cos inverse 2 by root 5 is equal to sine inverse 1 by root 5. So actually we need the value for tan theta. We don't need this one. हामीलाई यो चाहिएको छैन, theta is equal to sine inverse 1 by root 5, but we need what? Tan theta, isn't it? Because we are converting this cos inverse 2 by root 5 in terms of tan inverse. So no need of finding this sine inverse, okay? So now therefore tan theta is equal to sine theta by cos theta, right? Or tan theta is equal to, what is tan theta is equal to? Sin theta by cos theta. You know this formula. What is sin theta? Sin theta is 1 by root 5. And what was cos theta? Cos theta, you can check You copy. So cos theta is equal to 2 by root 5. It is 2 by root 5, right? Root 5 gets cancels. So what is tan theta now? Tan theta is equal to half, right? So what's the value for theta now? So you can take that tan to the right hand side. So theta is equal to tan inverse half. Theta is equal to tan inverse 1 upon 2. Is that clear now? So cos inverse 2 by root 5 was assumed as theta, and theta is equal to tan inverse half. That means cos inverse 2 by root 5 in terms of tan inverse is tan inverse half. So what can we write here? Therefore, cos inverse 2 by root 5 is equal to tan inverse half. So we have got the value for cos inverse 2 by root 5 in terms of tan inverse, that is, it is tan inverse 1 upon 2. Okay, so left hand side is equal to, so LHS is equal to 4 within bracket. What is tan inverse 1/3? Tan inverse 1/3, it is kept as it is, that means it remains same. Tan inverse 1/3 plus, what is cos inverse 2 by root 5? It is tan inverse half. It is tan inverse half, right? Now you can use this formula. What is tan inverse x plus tan inverse y? Now you know this formula, isn't it? Tan inverse x plus tan inverse y is equal to tan inverse within bracket x plus y whole divided by 1 minus xy, right? So it's equal to 4 tan inverse within bracket. In the numerator, what is x plus y? 1/3 plus half divided by 1 minus xy. That is 1/3 into 1 by 2. Is it clear now? So now we can simplify it, which is equal to 4 tan inverse. So within bracket in the numerator, what's the LCM? 3 and 2. Its LCM is 6, isn't it? 6 is divided by 3. 2 ones are 2 plus 3. You know that, how to simplify it. So what's the LCM in the denominator? It is 6. So 6 ones are 6 minus 1. Right? So here you can cancel this 6 is equal to 4 tan inverse. Now this is 5 divided by 5. So 5 ones are 5, 5 ones are 5 is equal to 4 tan inverse. This is 1. Is that clear? So now this is your tan inverse 1. Okay. So instead of 1, you can convert this tan inverse 1 in terms of tan inverse tan x form, isn't it? So you should write 1 in terms of tan. So tan ko kun sa angle is 1? Tan of which angle is 1? Tan of pi by 4. You know that, isn't it? So write down is equal to 4 tan inverse. It is tan of pi by 4. Always write down the angle in terms of circular measure or in terms of radians, right? So next is equal to 4 into, what is tan inverse tan pi by 4? It is pi by 4, right? So here 4 gets cancels, which is equal to what? Pi, which is equal to right hand side. Okay, so it is proved. Understood? So left hand side is equal to right hand side, which is equal to pi. Is that clear to all of you? You can copy it. We'll do the next question now. Now we will do question number 5. This is also proof that LHS is equal to RHS, right? So what is left hand side here? 2 tan inverse 1/3 plus sine inverse 4 by 5. You have to prove this left hand side is equal to pi by 2. Okay. So let us write down this left hand side. That is 2 tan inverse 1 upon 3 plus sine inverse 4 by 5. So how will you do this problem? Since the second term is in terms of sine inverse, this 2 tan inverse 1/3 should be converted into sine inverse. So what is the formula? What is 2 tan inverse x in terms of sine inverse? You should know this formula. We have done it, isn't it? I proved it also. So the formula is 2 tan inverse x is equal to 2 tan inverse x is equal to, what is the formula? In terms of sine inverse, it is sine inverse 2x divided by 1 plus x squared. So in this case, we need to convert this 2 tan inverse 1/3 in terms of sine inverse. so that in this problem you can use the formula of sine inverse x plus sine inverse y. Is that right? So I think I've understood it. So let us convert this to tan inverse x in terms of sine inverse, right? So is equal to sine inverse within second bracket 2 into what is x? 1/3 divided by x. Here is 1/3. 1 plus what is x whole square? It is 1/3 whole square. So second bracket is closed. Plus this is your sine inverse 4/5, right? So is equal to sine inverse within bracket. This is 2/3 divided by 1 plus 1/9. Bracket closed. Plus this is sine inverse 4/5, right? So let us simplify it. You have to simplify the first term now. So how can you simplify it? Which is equal to sine inverse. So now this is 2/3 divided by 9 ones are 9 plus 1, 10/9. 10/9, bracket closed. Then plus sine inverse 4/5 plus sine inverse 4/5, right? So which is equal to, this is your sine inverse within bracket. Now we can cancel that. 2 ones are 2, 2 5s are 10, 3 ones are 3, 3 3s are 9. That means 3/5. So this is your sine inverse 3/5 plus sine inverse 4/5 plus sine inverse 4/5. That is sine inverse x plus sine inverse y. Is that clear? So now let us use the formula for sine inverse x plus sine inverse y. So can you tell me what is sine inverse x plus sine inverse y? What is the formula? So sine inverse x plus sine inverse y is equal to, what is the formula now? It is sine inverse x root under 1 minus y square plus y root under 1 minus x square, right? So this is the formula that you can use here. So instead of x, what is there? 3/5. Instead of y, what is there? It is 4/5. Okay. So which is equal to sine inverse. Now let us write down the formula using this formula. Let us write down this. So what is x? 3/5. 3/5 root under 1 minus. What is y whole square? What is y whole square? This is 16/25. Right? Next, plus sign is there. If it is plus, you should write plus here. And what is y in this case? It is 4/5 root under, what is 1 minus x square? 1 minus, this is, what is x whole square? 3/5 whole square. That means it is 9/25. Right? This is your 9/25. Is that clear? So which is equal to sine inverse within bracket 3/5 into, let us simplify it. Within square root, it is 25 ones are 25 minus 16. Kati bhayo? Root over 9/25 plus next 4/5 into within square root. It is 25 ones are 25 minus 9. What is it? 16/25. Is that clear? So now let us simplify it. Sine inverse within bracket 3/5 into, what is square root? 9/25. This is 3/5, right? So plus 4/5 into, what is square root of 16/25? That is also 4/5, right? So let us simplify it. Sine inverse within bracket, this is 9/25 plus 16/25. Okay? So which is equal to sine inverse within bracket, what's the LCM? It is 25. This 25 is divided by 25. That is 1. 1 9s are 9 plus, again 25 is divided by 25. That is 1. Again 16 ones are 16. Right? So now, which is equal to sine inverse. Sine inverse, what is 9 plus 16? It is 25 divided by 25, isn't it? 9 plus 16 चाहिँ कति भयो 25 divided by 25. Now you can cancel it. 25 ones are 25, 25 ones are 25. So which is equal to, this is your sine inverse 1. Is that clear? Now next, if this is sine inverse, you should write 1 in terms of sine. So sine ko kun se angle se 1 hota. Sine of which angle is 1? It is sine 90 degree. That is 90 degree. You should write it in terms of radian. That is sine pi by 2. So is equal to sine inverse sine pi by 2. Which is equal to, what is sine inverse sine pi by 2? That is pi by 2. You know the formula, isn't it? What is sine inverse sine x? That is x. So what is sine inverse sine pi by 2? It is pi by 2. So which is equal to right hand side. So it is also proved. Understood? So we can copy it. We'll do the next question now. So now let's do this question number 10. This is also prove that you have to prove this LHS is equal to RHS, right? That is tan inverse 1 upon P plus Q plus tan inverse Q upon P square plus PQ plus 1 is equal to cot inverse P. Okay, so let's prove it. This is also tan inverse X plus tan inverse Y. Now you know the formula, isn't it? So which is equal to tan inverse within second bracket. Let us write it within second bracket. What is X in this case? 1 upon P plus Q plus Q upon P square plus PQ plus 1. This whole divided by 1 minus xy, isn't it? 1 minus 1 upon P plus Q into, this is X, 1 minus X into Y. What is Y here? It is Q divided by P square plus PQ plus 1. So here second bracket is closed. You could have written here first bracket also or third bracket. Okay. So now what will you do now? So you should simplify it. So which is equal to, now next, in the next step, what will you do? You should find out the LCM in both the numerator as well as in the denominator. Okay. So it's equal to tan inverse. Now within second bracket, in the numerator, what's the LCM? It is P plus Q into what? P plus Q into P square plus PQ plus 1, isn't it? So it is P square plus PQ plus 1, right? Now this LCM is divided by P plus Q first. That is P plus Q will be cancelled. Then P square plus PQ plus 1 will be there. It should be multiplied by 1. So what do we get? It is P square plus PQ plus 1, right? Then plus sign is there. Plus. Now again that LCM, this LCM is divided by P square plus PQ plus 1. So here P square plus PQ plus 1 will be cancelled and you will get P plus Q, isn't it? So this P plus Q should be multiplied by this numerator, that is Q. So Q into P plus Q. Q into P plus Q. Okay, understood? So what's the LCM now again here? Same LCM is there. P plus Q into P square plus PQ plus 1. Because here it is P plus Q into P square plus PQ plus 1. Right? So what will be in the numerator? Okay. यो जुन चाहिँ डिनोमिनेटर को माथिपटि छ यो यसमा एक्सप्रेसन अब के हुन्छ भन्दा फेरि यो P plus Q into P square plus PQ plus 1 should be multiplied by 1. Okay. So P plus Q into P square plus PQ plus 1. Right? Then minus. Now this LCM is divided by this two factors. That is 1, isn't it? So 1 into Q is minus Q. So here second bracket is closed. So this is the simplified form, isn't it? So here you can cancel this common term from both the denominators, right? So P plus Q, P plus Q, P square plus PQ plus 1 will be cancelled, isn't it? So which is equal to tan inverse. Now within second bracket in the numerator, what will you write? p square plus pq plus 1 plus, again multiply by q there, it is pq plus q square. So this whole divided by, now we have to multiply these two factors, right? P into p square, p cube plus multiply by p here. First of all, you multiply by p into p square, p cube plus p into p square cube plus p, right? Plus p, okay? Then multiply by q here plus, now multiply by q, it is p square q plus, this is p square q plus pq square, ठीक सर? अब plus q, अब यहाँ आउँदैन, यहाँ मुनि बाट लेख्दैछु है, plus q into 1 is plus q, then minus q, so here second bracket is closed. So is that clear now? I think I've understood it. So here plus q minus q gets cancels. So now let us simplify it, which is equal to tan inverse within second bracket. Let us write p square first. This is the only p square there. What is pq plus pq? Plus 2pq. Then let us write down plus q square, then plus 1. So this whole divided by. Now denominator, you should simplify the denominator also. That is p cube. This is your p cube plus, this is p square q plus p square q. What is it? Plus 2p square q, right? Then you have to write down plus pq square plus pq square, then write down plus p. So here second bracket is closed, right? Is that clear? So now in the denominator you can take common, isn't it? What is common in the denominator? That is p. Only there is common in the denominator, that is p. So it is equal to tan inverse within second bracket, it is p square plus 2pq plus q square plus 1 whole divided by, what is common in this case? It is p. So within bracket p square plus 2pq plus p is taken common, q square plus 1. First bracket closed, then second bracket is also closed, right? Now we can cancel this. This is one time. We can cancel it, right? So is equal to tan inverse within bracket, you should write 1 by p, right? So this is tan inverse 1 upon p. But you should convert into cot inverse p. You know that. You know this formula, isn't it? That is, if you have tan inverse x, what is it in terms of cot inverse? It is cot inverse, it is upside down, that is 1 upon x. Similar here also, which is equal to cot inverse within bracket 1 upon 1 by p, isn't it? Instead of x there is 1 by p, so formula is cot inverse 1 by x, so it is cot inverse 1 by, what is x here? 1 by p. So write it in the denominator. When you simplify it, this p goes up in the numerator, so which is equal to cot inverse p. So it is proved. Okay, so this is the answer. Understood? So you can copy it. We'll do the next problem now. So now we'll do the next question, that is question number 11. So in this case also you have to prove that, okay? Tan inverse 3 by 2 plus tan inverse 6 by 5 is equal to, what is there on the right hand side? It is pi minus tan inverse 27 by 8, right? So let us write down the left hand side. That is LHS is equal to tan inverse 3 by 2 plus tan inverse 6 by 5. So in this case also you can use the same formula, that is tan inverse x plus tan inverse y. So what is the formula now? It is tan inverse x. What is x here? 3 by 2 plus what is y? It is 6 by 5 whole divided by what? 1 minus xy. 1 minus xy is 3 by 2 into 6 by 5. Is that clear to all of you? So now, which is equal to tan inverse within bracket, what's the LCM in the numerator? That is 2 5s are 10 is the LCM. 10 is divided by 2, that is 5. 5 3s are 15. Plus 10 is divided by 5, that is 2. 2 6 are 12. So here also, you don't have to cancel it. Don't cancel it. 5 2s are 10. 10 is the LCM. Okay. So 10 1s are 10 minus 18. Right. So here 10 10 gets cancelled. You may cancel it here also and then you can simplify it. But since we are getting 10 here, that's why you can cancel this 10 10. So it is not, that's why it is not cancelled here, isn't it? So that you can get 10 here directly, we can cancel this to 10, right? So which is equal to tan inverse? Which is equal to tan inverse within bracket 12 plus 15 is 27 divided by, what is 10 minus 18? This is minus 8. Is that clear? So which is equal to tan inverse? So it is minus 27 by 8. But you have to prove pi minus tan inverse 27 by 8. So how can you prove it? So tan of which angle is minus 27 by 8? We don't know. Tan of which angle is minus 27 by 8? Actually, we don't know, isn't it? This is not the standard value. Okay. So how will you simplify it? You know that tan is negative in the second quadrant. Tan is positive in the first quadrant and in the third quadrant. But tan is negative in the second quadrant and in the fourth quadrant. Right? Tan is positive in the first quadrant and in the third quadrant. But tan is negative in the second quadrant and in the fourth quadrant. Clear? So now let us find this angle in the second quadrant. So how can you find it? Let us assume tan inverse minus 27 by 8 is equal to theta. Okay? This right hand side, what is right hand side? Pi minus some angle, 180 degree minus some angle. That some angle is taken as theta. So pi minus theta always lies in the second quadrant. That means you have to find out the angle in the second quadrant, right? So tan inverse goes to the right hand side, it becomes tan. So minus 27 by 8 is equal to tan theta. Is that clear? Next one is 27 by 8 is equal to minus tan theta, right? Or 27 by 8 is equal to, so tan theta is negative in which quadrant? Second quadrant, right? That is the least value, second quadrant, right? So tan of, you should write here pi minus theta, because you know the formula. In class 11 you did trigonometrical ratios of associated angles, isn't it? That in that case tan 180 degree minus theta, what is this formula? Tan 180 degree minus theta. 180 degree minus theta lies in the second quadrant, and in the second quadrant tan is always negative, minus. And since 180 is even multiple of 90, so tan remains same. It does not change, right? Whenever it is even multiple of 90, trigonometrical ratios do not change. But if it is odd multiple of 90, trigonometrical ratios will change. Okay? Sine changes to cos, cos changes to sine, tan changes to cot, cot changes to tan, sec changes to cosec, or cosec changes to sec. So in this case, it is 90 into 2, that is even multiple of 90. So tan remains same, it does not change. So it is minus tan theta. Right? So 180 degree is pi, you know that. Degree in terms of radian, 180 degree is equal to pi radian, right? So you can write pi minus theta. Again, tan, take it to the left hand side. So tan inverse, it is 27 by 8 is equal to, this is pi minus theta. Okay? So minus theta, take it to the left hand side. It becomes theta is equal to, minus theta becomes plus theta on the left hand side, and this goes to the right hand side. What does it become? Pi minus tan inverse 27 upon 8. Is it clear now? So what was our left hand side? Our left hand side ki thiyo? The left hand side was this one, isn't it? Tan inverse minus 27 by 8, right? But this was assumed as theta. So which is equal to, this was assumed as theta, and what is the value for theta in this case? It is pi minus, isn't it? So instead of theta, what can you write? It is pi minus tan inverse 27 upon 8, right? So instead of theta, what can you write? It is pi minus tan inverse 27 by 8. Is that clear? So which is equal to right hand side. So it is also proved. You will prove by you. So you can copy it. Let's do the next problem now. So now we will do this problem. Prove that. This is question number 12. What is there on the left hand side? It is tan within bracket half sine inverse 2x upon 1 plus x squared plus half cos inverse 1 minus x squared by 1 plus x squared. You have to prove this is equal to 2x upon 1 minus x squared, right? So now you should know this formula also. There is a formula for sine inverse 2x upon 1 plus x squared and cos inverse 1 minus x squared upon 1 plus x squared. You should know the formula also. Suppose we don't know the formula, okay? Suppose I have formula. So you have to do the trigonometric substitution here. This is the method of trigonometric substitution if you don't know the formula, right? So what will you put for x here so that it can be in the form sine inverse sine theta? You may not get sine theta, it may be sine theta, sine 2 theta, sine 3 theta, etc. Here also, what should be the trigonometric substitution for x in this case, in the second term? It is cos inverse 1 minus x square upon 1 plus x square. So you have to put x as a trigonometric function in such a way that you should get cos inverse cos theta form. It may be cos theta, it may be cos 2 theta, it may be cos 3 theta, like that. Okay? So यसमा चाहिँ हामी के गर्छौं? Trigonometric substitution गर्छौं. ठीक छ? So 2x upon 1 plus x square, x is equal to sine inverse sine form ma आउँछ यो. That is, you know this formula, you should know this formula, that is sine 2 theta in terms of tan theta, isn't it? From trigonometry you know that. So sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta, right? So if you substitute tan theta in terms of x, tan theta instead of x, then 2 tan theta upon 1 plus tan square theta, directly you can write sine 2 theta. So it will be sine inverse sine 2 theta. Is that clear? Next, this is half cos inverse 1 minus x square upon 1 plus x square. So in this case, what will be the trigonometric substitution? So what will be the trigonometrical substitution for x in this case? So that we can have cos inverse cos theta or cos inverse cos 2 theta form. You know the formula cos 2 theta in terms of tan, isn't it? What is cos 2 theta in terms of tan theta? It is 1 minus tan square theta divided by 1 plus tan square theta. These are the two formulae that you can use here. Is that clear? So let us assume in this case you put x is equal to tan theta. In this case also you put x is equal to tan theta, so that you can use these two formula. So these two formula are from the chapter of trigonometry, that is multiple angles, right? So now this is your left hand side. Let us write down the left hand side. You have to prove 2x upon 1 minus x square, right? So this is your LHS. So LHS you write on this left hand side. So let us assume x is equal to tan theta. So you can get the value of theta here. What is theta is equal to? What is theta is equal to? Theta is equal to tan inverse x. We may or may not use this value for theta. Okay. So let us find it. Theta is equal to tan inverse x. निकालिराखौं theta is equal to tan inverse x भनेर. ठीक छ? त यो युज हुनु पनि सक्छ नहुनु पनि सक्छ. ठीक छ? So LHS is equal to tan within bracket. This is half sine inverse. What is it? 2 tan theta upon 1 plus, this is tan square theta plus half, then cos inverse, this is your 1 minus tan square theta divided by 1 plus tan square theta. Is that right? So now let us use the formula. So is equal to tan, let us use here second bracket, half sine inverse. So now, what is the formula for 2 tan theta upon 1 plus tan square theta? Just now we wrote it here in the rough part. Just now we wrote it. What was that? 2 tan theta upon 1 plus tan square theta. You take a formula, it is sine 2 theta. Right? Plus half cos inverse within bracket. What was the formula for 1 minus tan square theta upon 1 plus tan square theta? This is from multiple angles. This is your cos 2 theta. This formula is cos 2 theta, right? So here second bracket is closed. Is it clear to all of you? So is equal to tan within first bracket half into, it is just like your sine inverse sine x, which is equal to x. What is sine inverse sine 2 theta? It is 2 theta plus half into, again, what is cos inverse cos 2 theta? It is 2 theta. Bracket closed. Okay? So you can cancel this 2, 2. Here also 2, 2 gets cancels, right? Now in the next step, which is equal to tan within bracket theta plus theta, which is equal to tan, what is theta plus theta? 2 theta, tan 2 theta. So let us write down the formula for tan 2 theta. So you know the formula of tan 2 theta from multiple angles. What is the formula for tan 2 theta in multiple angles? What is the formula for tan 2 theta? It is 2 tan theta divided by 1 plus tan square theta. Okay? So यो सब याद हुनुपर्छ है. मैले पहिल्यै भनिसकेको छु तिमीहरूलाई कि ट्रिग्नोमेट्रीको कतिवटा च्याप्टर्सको फर्मुला तिमीलाई याद हुनुपर्छ. अझै पनि म भन्दैछु. You should know the formula from the chapters of trigonometry. That is trigonometrical ratios of associated angles, next compound angles, transformation of products and sums, multiple angles and submultiple angles. Okay, the formula for all this chapter you should know that. Okay, you should know all this formula from all these chapters that I just told you. Okay, so now what is the formula for tan 2 theta? It is 2 tan theta divided by 1 plus tan square theta, right? So which is equal to, what is the value for tan theta in this case? It is x. No need to use this formula, theta is equal to tan inverse x. So your theta is equal to tan inverse x and use गर्नु पर्दैन. No need of using this theta is equal to tan inverse x. Only you have to use x is equal to tan theta. Okay, so what is tan theta here? X. So it is 2x divided by, it is 1 plus x square. So we have got the answer, which was 2x upon 1 plus x square on the right hand side, isn't it? So we have proved LHS is equal to RHS. Is it clear to all of you? So this is important question, right? So you can practice it at home. So now I'll give you the homework. So now these are your homework. Question number 2, 3, 4, 6, 7, 8 and question number 9. You can do it at home. I'll give you the hints also. In question number 2, tan inverse half plus tan inverse 2 by 11 is equal to cos inverse 4 by 5 is there. Okay. So write down LHS, tan inverse x plus tan inverse y. Use the formula of tan inverse x plus tan inverse y. You know that tan inverse x plus y upon 1 minus xy. Simplify it. Using x is equal to half and y is equal to 2 by 11, you will get in terms of tan inverse. Then convert that tan inverse in terms of cos inverse. You know how to convert it, right? So this is number 2. And in question number 3, sin inverse 77 by 85 is given minus cos inverse 15 by 17 is equal to sin inverse 3 by 5. Since you have to prove this sin inverse 3 by 5, convert this cos inverse into sin inverse, then use the formula sin inverse x minus sin inverse y. Is that clear? You can do it. Now in this case, number 4 is there. You have to prove 2 into tan inverse 1/4 plus tan inverse 2 by 9 is equal to cos inverse 3 by 5. So first of all, simplify this tan inverse x plus tan inverse y. You can use that formula, tan inverse x plus tan inverse y. X is equal to 1/4, y is equal to 2 by 9. Okay, use the formula. Then you will get in terms of 2 tan inverse, some number will be there. It will be in the form 2 tan inverse x. Then you can convert this 2 tan inverse x in terms of cos inverse. That is 2 tan inverse x is equal to, you can use this formula. That is 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. So after you simplify left hand side, you will get in the form of 2 tan inverse x. There will be some numbers for x, isn't it? That is 2 tan inverse x should be converted into cos inverse 3 by 5 form. So use this formula. 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. Is that understood now? So you can use this formula here. Okay. Now next, number 6. Cos inverse 2 by root 5 plus sin inverse 1 by root over 10 is equal to, you should prove pi by 4. So either you can convert cos inverse into sin inverse or sin inverse into cos inverse. एउटा मात्रै चेन्ज गर्नु. यदि यो cos inverse लाई sin inverse मा चेन्ज गर्यो भने use the formula sin inverse x plus sin inverse y. If you convert this sin inverse into cos inverse, then use the formula cos inverse x plus cos inverse y. You can do it. Okay. So question number 7. 2 sin inverse 3 by 5 plus sin inverse 7 by 25 is equal to pi by 2. So how to do it? This 2 sin inverse x should be converted in terms of sin inverse. So which formula is used here? 2 sin inverse x is equal to, which formula is used in this case? You can use the formula sin inverse 2x root under 1 minus x square. So for this term 2 sin inverse x form, you can use this formula, sin inverse 2x root under 1 minus x square. Okay, so it will be converted in terms of sin inverse x form. That is using this formula, sin inverse 2x root under 1 minus x square. Then you can use again sin inverse x plus sin inverse y, so that you can prove pi by 2. Is it clear? Now I think you can do this number 8. Tan inverse 1/3 plus tan inverse 1 by 7 plus tan inverse 1 by 5 plus, this is the continuation part. Since there was no space, so I wrote this tan inverse 1 by 8 here. Okay. So tan inverse 1/3 plus tan inverse 1 by 7 plus tan inverse 1 by 5 plus tan inverse 1 by 8 is equal to pi by 4. So you have to take the terms in pair. Okay. This is tan inverse 1/3 plus tan inverse 1 by 7. First simplify it using tan inverse x plus tan inverse y. Right. Again you can simplify the next two terms. That is tan inverse 1 by 5 plus tan inverse 1 by 8 using the same formula, tan inverse x plus tan inverse y. Okay. Then again after simplification, again you have to use the same formula, that is tan inverse x plus tan inverse y, to get pi by 4. So you can do it at home. So what is question number 9? It is tan inverse x plus cot inverse x plus 1 is equal to tan inverse 1 plus x square. Can you do it? Since this is in terms of tan inverse x, convert this cot inverse x plus 1 in terms of tan inverse. What is it in terms of tan inverse? What is cot inverse x plus 1 in terms of tan inverse? It is cot inverse x plus 1 is equal to tan inverse 1 upon 1 plus x. So for this you can write tan inverse within bracket 1 upon x plus 1, right? This formula should be used for cot inverse x plus 1. That is cot inverse x plus 1 is equal to tan inverse within bracket 1 upon x plus 1, right? So tan inverse x plus tan inverse 1 upon x plus 1 will be there. So you can use the formula of tan inverse x plus tan inverse y. Okay. So you can go through this problem. You can do it at home. I think you can do it. Okay. So एकपल्ट तिमीले ट्राई गर्नु भएन भने मलाई सोध्नु सक्छ. ठीक छ? त आजलाई हामी यति नै गर्छौं ल. फेरि हामी नेक्स्ट क्लासमा अझै मोर प्रब्लम्सहरु गर्नेछौं.